Internet of Things, the big problem that we're talking these days is mobile and the devices that we're all screwing around with here all day long. And I'm going to hand it over to Georgia. You've got the room. It's all yours.
Okay. Hi, everybody.
Hi, Georgia.
I can't say that I have ever given a presentation into somebody's living room before, but first time for everything. This is actually the second time I've given a presentation where I wasn't wearing pants, so take that how you will.
Yeah.
Okay, there's obviously a delay on the audio because you guys laugh like 5 seconds after I say something, so I'll try and take that into account. Yes, the devices, this is Google Glass, obviously. I haven't done anything with the Google Glass yet, but it's just Android, so it's on my very long list of things to do somewhere near the top to write payloads for this, you know, just to show off how cool I am. I hope nobody's attaching their Google Glass to their corporate Wi-Fi just yet, but probably they are. So, alright, so what we're going to talk about today, I made some slides just for you guys. Whoa, where did it go? It just broke. Can you guys still hear me? Because I can't see you anymore. There we go. Okay. Alright, slides. So I need to share my screen. We learned how to do this like 2 days ago. Here we go. Screen share. And I will just show the whole thing and we'll make a scary loop. So now you can see yourselves, right?
Yes.
Yes.
Okay, cool. Alright, so now I want slides. And so I made these slides, and they actually have a background. If you've ever seen one of my presentations before, it's always either been black and white or white and black, but I actually made real slides just for you guys. Okay, so Wim came up with the name, or not Wim, Wim is another person altogether. Alright, so the bring your own device issue. I think that this doesn't get enough attention from the attackers, perhaps. You know, a lot of people love to use like bring your own device as a buzzword, but then when people call it out on Twitter and say, when was the last time a company actually was breached and somebody found out that the reason why was because somebody had a mobile device on the network, and nobody can think of any issue that's ever happened, ever. Not even me. So the attackers really need to get on it and start proving me right. Or maybe they can wait a little while because I need time to build my professional product, so then I can make a lot of money based on it. So they can wait. But eventually, they've got to do something about this because it's really kind of easy. And I guess the real reason that nobody's attacking bring your own device is because it's still so easy to just attack Java or get somebody to open an email attachment. So maybe if people start actually being secure, people will attack mobile. But whatever. Anyway, so mobile devices. Theoretically, it should be really hard to jump from a mobile device onto the actual machines in the enterprise, but in most cases that I've ever seen, it's been like, dude, can I get on your wireless? And even in corporations, it's just been, they just dump me in with everybody else. That's not always true. Like, I saw Paul in the audience from Dynetics, I think, and they have a guest network, and that was good. But most places, it's, you know, I just kind of take a look around at what network I'm on, and it's like, wow, you can kind of see everything. I used to work for a government agency. We actually had the same thing going on. Everything was all on one same network, all the printers, all the mobile devices, all the everything. There weren't that many mobile devices back then. But if you knew the wireless password, you could just put yourself on there, and, you know, that happens. But even if, let's say, corporate network's good, we actually secured things, but the laptop from work goes home and it has a VPN back to work, because, you know, we all like to work from home. Our companies want us to work on the weekends, so we VPN back to work. Probably our home network not going to be as secure. I personally have real problems typing in passwords into the printer, so I like to leave my wireless open. I live in the country. I can get away with that. My neighbors can't see it. They can't even see it from the road. But it's still not a very secure thing to do. But most home networks, probably pretty simple. I don't know very many people who have, like, partitioned guest networks. If they do, they're probably very geeky. Your normal, average individual, probably not. So they're mobile devices. are going to definitely get on the same network as their work laptop. So if their work laptop happens to have any vulnerabilities, you will have direct access to it. Same situation, you kind of breached the perimeter, you're in the local network. We didn't have to do any of the trouble of getting through, like hopping on the wireless or getting through the perimeter through like social engineering or anything. We just popped in through the mobile device, and we have direct access to any of the other devices in the network. I don't know about you guys, but if you did an audit on my home network, it would probably come up to be pretty pathetic, particularly because I actually teach information security, right? So I have all these vulnerable virtual machines lying around, and I forget to turn them off, and I install software because I'm trying to write exercises for my exploit dev class, and again, I forget to turn it off. And I used to do this when I worked at actual companies, and no one ever said anything about the like vulnerability from 1998 that I just left on a web server on my workstation that had all my client reports on it too. So, you know, we just get away with these things. No one pays attention. So I have mobile device. Am I really making that big of a difference? Probably not, but it's another way we could infiltrate. So I made a little nice picture here, and see I have my little company logo in the corner too. I'm rather proud of that. I'm going to be a real businesswoman now, not just a weird hacker. All right, so I guess the big question that people have is, can you actually attack a mobile device? Can you well, obviously you could attack it, but can you successfully attack it? So just kind of have a few examples of mobile attacks here. So like remote mobile attacks, I say they're rare, and I would say they're on par with remote attacks of other devices, like, you know, MSO 8067 was a big deal, but that was, you know, XP. People unfortunately still fall victim to it, but hopefully they've patched it. The vulnerabilities that are coming out now, we see a lot more client-side, you know, the browser stuff, use after freeze, Java, Adobe Reader, things like that. We don't see as many remotes by any means as we used to, so they do on occasion happen. But most of the remotes you're going to see are just bad add-on software, unlike your Windows 7s and whatnot, where data execution prevention is off by default on anything that's not a Windows DLL. Then, you know, somebody installs something and it's got an old school vulnerability on it, and that's how you get popped. It's kind of the same thing with the mobile devices. There's nothing to say, or I couldn't have an app that listens on a port or something, then we'd have a remote attack. But there's been some, like just this past Black Hat, Karsten Noel talked about his SIM card attacks, where he basically attacks the cryptography of the SIM card and then gets them to run payloads and convinces them it's legitimate from the carrier because they use bad crypto. Who knew people use bad crypto? And even if you use good crypto, the NSA is watching anyways. Seriously, I was not surprised by this, because I think if I can make your phone do this, I'm sure the government can. What was the movie me and Mom were watching the other day? We were watching this movie. We were watching Enigma about, like, Bletchley Park, and Mom was just like, why did we not assume people were watching us if, like, in the 40s they were doing this? So that's just my side note. But anyway, remote attacks occasionally happen. In that case, you know, you don't even have to do anything. You can't really blame the loser. I mean the user, but I mean the loser. The person who's using the phone, because they didn't even do anything. Their phone was just vulnerable naturally. So things like cell tower attacks, where you put up a malicious cell tower. Like if you've ever gone to China and every app on your phone suddenly wants to update the minute you hit the Chinese cell towers, that's an example of malicious tower. It just, you know, the Chinese government approve of this. They want to spy on everybody. Probably our towers are doing it too, and we just don't talk about it. So remote attacks happen, and that we can't really fix if we don't know about it, because we can't really tell users don't click on this, and we can't really use mobile device management to segregate something that's like a SIM card vulnerability. They just don't work that way at this point, at least none of the ones I've ever looked at. But then, you know, our more prevalent client-side attacks, our entire world is taken up with them. You'd think if we got rid of all the remote vulnerabilities, we wouldn't have any more vulnerabilities anymore, because no one would ever open nasty stuff in their applications. Unfortunately, I open nasty stuff all the time. I use a Mac. We don't get viruses, right? So I don't have to worry about that stuff. But people open stuff. I thought about it just the other day that I was like, well, how many times a week do I do something like click through a certificate or install something on my Mac that says this hasn't been signed? Like I was downloading new stuff for Android SDKs and one of the packages wasn't signed and it gave me a warning, but I wanted it because I want to build something for Glass, right? So I installed it. So I thought about it. Even me as a security person, how many times per week do I do something that I would tell my users not to do? And it was probably a pretty high number, and if we think about it, it's probably a pretty high number for all of us. And our phones are just the same way. Everything that's on the phones that opens some sort of document or file could potentially be exploited. A vulnerability came out like Firefox earlier this year, where the official Firefox app would basically read anything from its private directory, including your stored usernames and passwords, and it would send them off. So nobody put that in there on purpose. It just happens. Secure coding is hard. I should know. I've never been able to pull it off. If you look up Smartphone Pen Test Framework in the open source vulnerability database, you will see I have a few entries there myself. So secure coding hard. Anything we open on mobile device could potentially hurt us. But when somebody sends me a link and it's somebody I know, chances are I'm going to open it. Which brings us to our social engineering. So I used to believe that social engineering was made up, and it didn't really work. Because it's like, who would actually open this? Like, my mom keeps sending me these ones because I'm trying to study malware analysis right now. So she just keeps sending me stuff that she gets in her spam. There's like stuff they want you to open, malicious PDFs, and it's like the grammar on them is just so terrible. And it's like, who would ever open this? I know there's better ones. I've seen some pretty good ones where it looks like, well, you just bought a TV off Best Buy and there's a problem with your order. And it's like, wait, I didn't buy a TV. Naturally, I want to see what's up because I think I've been hacked, right? So there we are. But, and in my case, if it's particularly early in the morning and I drank too much the night before, I will be more likely to click on stuff just in case you want to steal my stuff. There's your tidbit. You guys aren't laughing. I'm obviously still not funny after all these years. I have tried really hard to be funny. I'm just not. I give up. I'll be serious. All right, so...
You all last night.
What?
We didn't drink a single drink last night.
Okay, well, if I had known this was going to be at somebody's house, I totally would have driven up there. You guys are only like 8 hours away. I could have driven. I just, I spend a lot of time at conferences and staying in hotels and whatnot, so this opportunity to stay home and get work done, it was like, maybe I'll take it. But let's just say, nobody clicks on malicious links in emails, nobody answers the phone and gives the insurance agent their social security number over the phone. That never happens. So we know it does. But we've taught everyone in our organization that they're absolutely not going to fall for this. That means business probably never gets done because everybody suspects everybody, and you have to actually walk up to somebody's cubicle every time somebody sends you an email to make sure they sent it, but everybody's really working at home. So business basically ceases because social engineering doesn't work anymore. So let's pretend that that's really happening. Then you've got all these new communication methods with the phones, like SMS. That's text message, right? How can text hurt you? I don't understand that one myself. When somebody asks me, how can a text message hurt you? It's made out of text. Well, that one's hard to explain. But then you've got like near-field communication. Like if I leave on the near-field communication on my phone and just like walk into an elevator at a hotel, it pops up with tags. It's automatically scanned. Charlie Miller did some research on NFC, and I was kind of disappointed that he didn't make the whole world fall down. It seems like the implementation of NFC on Android is actually pretty secure from a remote perspective. But again, if you get people that, would you like to scan this tag? Would you like to scan this QR code? Things like that, and people say yes, then you've got them anyways. So we just need to convince the user to open something, and I've actually seen the carriers themselves get involved with this. It was a couple of years ago. Maybe they've learned their lesson, but I don't use that carrier anymore. The carrier wrote me and said I could download a security app of all things, and it was in a text message. It was from number like 1234. and it said, download this. There was a link in the text message, and it sent me to, you know, mobile.carrier.com or something.carrier.com, and, you know, it was a third-party app store. It didn't send me to Google Play, which is just a cardinal sin of security. We always tell people, try and stay in the official app stores. You know, they're not perfect, but at least they're trying. And here it was, the carrier was telling me to go out and use a different app store, so I did not much approve of that. That's really just telling us to do the wrong thing. And then, if we can get people to install an app, like in that case, malicious apps, particularly on Android, the APIs for Android, they really just can kind of let you, based on the permission model, do anything you want. On my Facebook today, I had posted a new blog post, and one of the jailbreakers for iPhone wrote me and said that, well, basically he was complaining that hacking Android is just so easy compared to iPhone, and that's absolutely true. Hacking Android, people say it's not even really hacking, which is why I obviously need to get into iOS hacking if people are going to take me seriously. But that said, Android is the most sold phone right now. It's the easiest to use. I have all four. I have Windows, BlackBerry. BlackBerry's usability is terrible. Don't use that one. Windows Mobile is pretty good. When my Android broke, I used that one as my second phone. iOS 7 I don't really like. iOS before that. From a usability standpoint, Android is the easiest for the layperson to pick up and use. It's also the easiest to develop for, and that said, it's also the easiest to write malware for. But it is possible to write malicious apps for all of them. Android just makes it easiest to upload it to their store or install it through a third party. But it is possible to write malicious apps for every kind of phone. But I like to write malicious apps, and I'm hopefully going to write one for the Google Glass very soon, and that will be, you know, kind of stunt hacking, because it's not really any different from hacking the phone, but it's Google Glass, so it's exciting. But just a few things on the slide. It says things you can do. You can make them steal data from the phone. You can remotely control it, like my original SMS botnet that I did years ago, which was at the baseband level, but you can also do it from the app level. It just made it send a text message. Like, you could grab everybody's contacts, send them a text message. Great way to infect other people, because it's, you know, taking that circle of trust and throwing it on his head. It's like, oh, my boss just sent me this and told me to download it, I'd better do it, as opposed to just some random number. And was that a question I heard?
Please.
Okay.
Here's a suggestion for an ad. Why don't you create some sort of strobe effect that makes people violently ill inside your Google glasses?
Could you repeat that?
He wants you to write an app. Do you remember what happened with the Japanese kids with the anime and then people having epileptic fits on certain highways?
Uh-huh.
The strobe effect. The Brit wants you to do this to people that have Google glasses to make them violently ill.
Geolocated specific.
Geolocated specifics only while they're driving or shooting guns.
Well, perhaps in a certain region of the world.
He's being a little serious, a little facetious.
Well, it would be a good proof of concept. It was like on that show Revenge, the guy had glasses and he watched somebody type in a password on it, so I was just going to see if I could turn on a camera in the background without turning on the light kind of thing. But yeah, making it take pictures would be cool.
You could turn it into a genuine crypto, whereby you might be able to sync that with some other device. So there might be real-world applications, cryptographic ones.
Yeah, I'll definitely look into that. When is this conference over? Are you guys going home today or tomorrow?
Well, after your presentation, there is one more on killing SCADA ICS. The bar is currently open. Dinner and stuff will be here, and then who the hell knows?
So you've got time to drive.
Yeah, I'm like, if I got there in like 8 hours, would you gonna still be there?
Well, wait.
Not in for work point.
You've got glass.
Okay, well, we better do the presentation. So what we're actually going to see the demo for today is we're going to see the last one, attacking other devices. There's a lot of videos out there. I've been messing with this stuff for years, so there's a lot of videos out there of it doing all sorts of stuff. If you look at the Bulb Security site, they're there. If you look at my old presentations. But we're just going to look at it being used as a pivot today. So the question is, how do we get an app easily that users will likely install, they'll likely trust, and how can we do this easily? Of course, we could just build an app manually, or we might want to replace an app that they already have or make it look like at least some sort of app that they might want and trust. You may have heard of the master key vulnerability on Android earlier this year. It got, a ton of press, probably because they used the term master key, even though it didn't have anything to do with master keys. But, PR people are smarter than me. They get more press, whatever. But basically, the vulnerability allowed you to replace another app that's already on the device, and Android would check the signatures for it, and it would say they were correct, even though you had modified it, potentially put in a backdoor, some other malicious functionality, but Android would say, yes, this is an update of the real app, but you never had access to the keys for it, you never had the developer key, so anyone who knows anything about crypto should say this should not work, you should not be able to sign something without having the private key, but the technical details of why this worked, I'll let you Google for, but basically it did, and it has been patched, but if you're familiar with Android, 99.9% of the devices you're going to run into, it hasn't been patched yet. All the ones in my house that we've bought since that patch came out, yes, we have it. All the ones before that, no, we don't. I have an Android here that's my mom's Android. I bought her a new one because I thought I lost this phone, but it is on Android 2.1, and it thinks it's up to date. And it's not even 2 years old yet, so technically she was still in contract when I just took this phone from her and bought her a new one. So this happens to our users. They're still vulnerable to old stuff, but we knew that. But they can't even try and patch it, which is terrible. But even without the master key vulnerability, I did write something. I just put out a blog post on it that goes through the script. But basically what it'll do is decompile an Android app, and it will add backdoor code, and it will put it back together, and it will sign it either with master key, either with one of your keys, or whatever you want to sign it with. So it'll look like the original app, so as far as the user can tell, and if you use master key, as far as even the Android system can tell, if it's vulnerable, it is the original app, but it in fact has some additional functionality. So the one I have for the example is ABC News, so it'll actually get news and stuff, but it also talks to me, so I put my SPF stuff in it. And you can do this programmatically. All you have to do is tell it what app to do. You may find random cases where developers develop something really weird and my algorithm doesn't know how to handle it, but I think I've pretty much got every normal case of how you build an Android app, how to do it. So by all means, prove me wrong and find one that it can't do. So we're going to look at my little smartphone pen test framework, which is a nice little open source tool. I currently have a real developer working on it, so we're actually getting a real command line interface, and the GUI is going to come back, and it's greatly, greatly going to expand. So if you have played with it before, wait a few weeks and then play with it again, because it's going to get much, much better. As the guy was like, well, it's called framework, but you have no way for people to hook up modules. Like, I don't know how to write that. So I have a real developer doing it now, and once he gets the framework in place, I can just follow it. I'm really good at mimicking what good developers do. So SPF is gonna get much, much better. But it's already pretty cool, I think, if you're into menu-based stuff, which a lot of people who are very technical are not, whereas a lot of people who aren't very technical really like the menu-based. So I guess it really just depends whether you like it or not. But basically what SPF is designed to do is automate exploitation for mobile devices. It's basically meant to be Metasploit for mobile devices. As of right now, most of it is for Android. There's a little bit for iPhone. I have the Windows Phone and the BlackBerry. I got them months ago, and I keep saying I'm going to put stuff for them on there. I will. I'm going to get to it. The idea is that it'll be able to do every known vulnerability for all 4 platforms, as well as take advantage of every API on all 4 platforms, as well as give you a way to build your own exploit, so kind of a Metasploit, like shellcode kind of way, where, you know, here's the shellcode for ARM to do, like, download and install kind of thing. So a lot of stuff I want to add to it that I'm hopefully going to get done this year, but you know how these things go. But it is open source, and it is now written in Python. When I first put it out, it was in Perl, and everybody hated that. But then I put it in Python, and nobody's complained about hating it, but they haven't actually turned in any patches to it either, so I don't know what the point was of changing it. But of course, the stuff in the mobile devices is in Java for Android and Objective-C for iOS and whatnot. So if you are a programmer and want to help, I would love to have your help. I might even pay you, actually. But it does, like, it has the build malicious apps in there. It'll hook up to Metasploit. There's really not much for mobile in Metasploit right now, so that's kind of, there's not much to it. It'll also, what I think is cool, that it lets you use the mobile device you already have for communication. So instead of having to buy some weird thing to send mobile attacks, you could either use your own phone or get like a USB modem and put your SIM card in it, and it'll hook up to that automatically. You don't have to worry about buying any special software or hardware, really. Alright, so what we're going to talk about specifically today, though I've just ranted on for 30 minutes already, we're going to talk about using the mobile device basically as a pivot. So we've gotten on the mobile device through a remote attack, through a client side, through a social engineering, some way, somehow, we got on the mobile device. I've done talks where all I talked about was ways to get on the mobile device. We talked about it briefly here, but I'm not going to demo it. But let's say you're on the device, we're in a network, doesn't matter whether it's home network or work network. I assure you there's probably a vulnerability, and I assure you that there's probably something interesting you want, regardless of where you end up, be it the coffee network. You know, the coffee network's probably got more interesting information than anywhere. You've got people from every company that's nearby there. So we are on some network, and we now have direct network access to every other device around me. We just need to find a vulnerability. And I showed at SkydogCon, let's see, where is it? I showed this at SkydogCon, where I used SMS, so text message, as a communication method, not only between, like, the black laptop, say that's my laptop, that's SPF, it's somewhere in the cloud somewhere, and it is talking to my controlled device, so that first iPhone at the top, that's my phone, that's part of SPF, which talks to the cell tower, which talks to an infected mobile device that's been infected by something through SPF, and is talking to a nearby computer. So it's on somebody's local network, and it's talking to a nearby computer. It exploits that computer. We'll see a demo of it. But instead of having that computer just use typical shell code and just call out to some listener on the internet, and then you see that red access point, that's the perimeter, any filtering or content inspection that they have there, we would have to deal with it accordingly. They might be able to stop us, log us, something. Metasploit does a pretty good job of getting through most content inspections, but just in case, I did have it instead have the shellcode callback. It was just a Metasploit reverse shell, just an inline, so it called back to a listener on this infected phone here at the bottom. So instead of calling out like that, basically having it call back out through the network, I had it call back to the phone, so I just opened up a TCP listener on the infected phone. You can do that as long as you have network permission. Like on Android, that's just a permission. iOS, all apps that get approved are allowed to talk on the internet. So you just open a TCP listener, and then I just basically funneled it into text messages. So I had it send background text messages out back to that control phone at the top, which forwarded it on to SPF. So if you find the SkydogCon video, everybody accuses me of being wasted. I actually wasn't. The drink that I had on stage was the first one I had that entire day, but people said I was drunk. I was just excited that it worked, because there's something a little bit crazy about doing a live demo where the cell towers have to be on your side, but I pulled it off. So that's also something it can do. We're not going to demo that today because like holding up all this stuff in front of the screen is silly and it doesn't work very well on emulators, but there is a video of that working. What we're going to do is basically this one, which is pretty much the same thing without the cell towers having to be involved so much. But basically how this first one works, what we need to do is compile exploit code to run on the mobile device. I'm currently working on something. This guy who was reading my blog post that I work with sometimes on exploit development had this great idea that it's like, well, why don't we just basically use TCP tunneling to send the traffic straight from Metasploit rather than all these extra steps. So I'm working on something where you can avoid this C code problem. But as of right now, you have to have C code because mobile phones don't have Python and Perl and Ruby interpreters and whatnot. But they can run C code. They're basically underneath it all. Everything except the Windows phone is basically, and I don't know what a BlackBerry is, the iOS and the Android. The major players, they are just Linux kernels really underneath, so they can run compiled C code if they're compiled with the right compiler. If I just compile it on my Linux box, obviously that won't work because these are ARM phones and they won't understand the assembly, but there are cross compilers for ARM and whatnot, so I can just compile it with a cross compiler, drop it onto the mobile device, and every app has the ability to store files. So it can just download something from somewhere and download it and save it and mark it as executable and then run it. So I can run exploit code as long as it's compiled appropriately. So my main downside to that is that I have to port my exploits to C, which I don't like, but I'm working on fixing that right now, like I said, and just allowing you to send any exploit that you want through the mobile pivot. And so then we can catch it. So basically, for this one, so I just have the shellcode I have is just it's Windows Meterpreter reverse TCP, the default Metasploit payload, and I put the lhost option, so who it's going to call back to, I set it as the IP address of, in my case, Kali Linux, where I'm running SPF, so it'll catch it. So it's just kind of traditional network exploitation, except it's happening through a phone, which I don't have direct network access, but I do have mobile network access to. Then again, this is even more exciting because I can avoid the perimeter, so I can basically avoid TCP/IP communication altogether, except for between this computer and the infected mobile device, which is all going to be on the same network. So while they may be doing some network monitoring, most people, even people who are doing security right, mainly deal with, is it leaving, is it coming in, because that's where it gets interesting, you know, if two computers, an infected computer talking to another infected computer inside the same network, shouldn't be giving anybody anything. So there is monitoring of that, but most of the people I see, they're really just checking on the perimeter. So if we can avoid the perimeter, we can make it even more exciting. So basically, like I said, open a listener, catch the shell on a listener on the device, and then send it out over SMS. So it is a little bit slow if you watch the video. I think it's got maybe a 1 or 2 second delay, but that's as fast as the pwn plug. And the pwn plug, you have to go drop it. This walks in by itself in someone's hands. So it's basically the same concept as a pwn plug, except it's somebody's actual device, so we don't have to worry about being in that physical location and having the ability to drop it. Alright, so other possible communication methods, other things I'm working on basically, you've probably heard of bad BIOS, which is another like weird misnamed thing, that basically a PR person came up with the name for that as far as I can tell. But basically the story behind bad BIOS was that they think that it may possibly have been emitting like ultra whatever, like outside of what dogs hear, whatever that is, sounds. So it didn't have to have any communication method like via the network because it was talking basically, which sounds pretty absurd in that case. But there has been, like, Ian Amit did some research a couple of years ago where he used like VoIP. He would use the VoIP network, so they would use their conferencing calls. It would call out and it would transmit like SIP commands to send their command and control. So voice stuff is possible, and I think with the phones it would be particularly possible if I could start a call in the background and then have it basically use text to speech even. I could do that and then have it catch, basically like have phone at the bottom make a call to phone at the top or vice versa and have it go out that way. So I'm kind of looking into that. It's another thing that's kind of on my list. NFC as well. Android really seems to want to lock down the NFC tag stuff to keep you from doing this sort of stuff, so it looks like it's at least going to require some social engineering to make the NFC stuff work, but it's like if I'm close enough, like outside maybe with a really strong tag transmitter, could I get an infected phone to send me stuff? So another thing I'm working on. And, you know, Bluetooth. Everybody loves to hack Bluetooth, so, I mean, basically if I can get somebody to pair to me, then yes, I can get it to send me stuff. But again, I'm going to have to be, or at least have some controller that's nearby enough. So these are other communication methods I want to work with. Basically, in the end, I want to have every communication method any mobile device has and make it do something bad. But as of right now, I've really only worked with traditional network, and my favorite text messages, I've made text messages do all sorts of nasty stuff. So. Alright, so let's look at some demos. That's me. I'll put that up at the end. But let's look at some demos, and hopefully my computer will behave. My computer has been telling me that I need to buy a new one for a very long time. I'm not sure why. It has 8 gigs of memory. It shouldn't be behaving this way, but it doesn't seem to want to run very many things very often. But I do have Android Emulator 1. Okay, so this one here, this is the SPF app. So this is controlled by the pen tester. So the pen tester basically needs to have some computer or tablet or something that's running SPF, and also some mobile device. So be it a smartphone that they own, or you can, again, USB connect. So you can just buy one of those little USB modem things and put your SIM card in it, and it'll talk through there as well. We need some way to, if you want to send any mobile-based attacks, you need something like that. So we've got that one here. We also have, this is the victim. It says it's Android 2.2. It doesn't make a difference. The lower number Androids just run faster. They don't take as much processing power. Like, try running KitKat emulator and try doing anything else on your computer and see how far you get. And then I have Kali Linux here with SPF on it. So I'll just have SPF right here. And I also have, this is just a VM that I use for exploit dev class. And my password is password, and I apparently can't even type that in. And this is just the example I use because I don't like to write in C code, and this was one that I did in C code, was to exploit WarFTP 1.65, which is pretty much the catch-all first exploit dev exploit anybody ever does. I do it in my class, so does Sans, so does Corlin, so does Sumil, so does everybody, because it's really simple, and before you know anything, it's really simple to write the exploit for, hence why I used that one, because I don't like to write in C. So this is just kind of an example. Anything that, at this point, that you can write the C code for, you should be able to do this for. But this is, again, just an example that's actually in the SPF repositories, the code for this, so you could set this up yourself if you wanted to play with it. So this is just XP with that. So I already have this device attached to me, and I can just like show you how easy it is to backdoor an app. So if I just go to backdoor Android APK with agent, it just asks me what app I want to backdoor. So I just downloaded ABC News. I pulled it off my phone. It rips it apart with APK tool, and then it puts basically the code from my Android agent and the original app together in Smiley, and makes it automatically start my code in the background. And then it asks me for some information, basically who's the controller for this, so basically what phone number can talk to it. It'll only talk to one phone, so I give it the phone number of this guy, so it'll only answer to me. It also takes a control key. Key 1 is a terrible key. I really need to switch this out for real crypto, but it's not really high on my list. And where can it check in over HTTP? So it can do SMS through that phone number or HTTP through a web server. So it'll change those values in the actual app, and then it will build it back together. And when it finishes, it will ask you, do you want to use master key? I'll just say no, and then it will let you sign it with your default key, whatever it is, and then you get them to install it somehow. I actually already downloaded it over here earlier just to make sure everything was good. So, and it's just the ABC News app, and it's going to install, and it says it's installed. So we say open, and here it looks like ABC News. It's even actually going to let me download. I get most of my news from testing this, honestly. It tells me what the latest news is when I open it. Sure, why not? And sure, why don't you just let it track me too? So rat-infested goat ship eludes trackers. So I learned something about what's going on in the world today because, I rarely leave my office because I backdoored this app. But it also has the SPF functionality in it as well. So if I tell SPF to attach to a deployed agent and I give it the information that I gave it when I built it, so the URL was Android Agent 1 and the key was key1 and communication HTTP or SMS. Let's just do HTTP. It's faster. Well, actually they're just as fast for the check-in, but let's just do HTTP. We can also have it check in over SMS, so again we can avoid the perimeter altogether. So what it's going to do is just basically do a three-way handshake with this guy to prove that it can communicate. So the user of this device sees no indication that this is happening, that they can even close the app. It's still going to run in the background. Basically, it just has something that listens for incoming text messages, and it periodically calls out to a web server to see if it has any communication. So typical botnet and then typical SMS botnet all rolled into one with a bunch of payloads. That's basically all this is. But it does take a minute for it to finish the check-in because it basically tries for a little while, and I haven't set it so once it gets an answer, it stops. It's just set to wait for 60 seconds. So that means I have to actually come up with something to say while we wait. This is always the worst part.
So Ali,
Georgia, there's a question.
Yeah?
have you actually spoke to anyone at ARM yet?
At ARM?
Hmm.
At the people who make the processors?
Hmm.
It's not really a processor problem, but I haven't. I've talked to people at Google, and they actually fixed, in KitKat, they fixed my background text messages. I've been doing the same attack for 3 years at the application level, and they finally fixed it. With KitKat, you have to, basically, if you have it, you've probably seen it, you have a default text message app, so the incoming intent, it isn't an ordered broadcast anymore. It will only go to that default app, so it actually broke some of my SMS stuff in KitKat. That said, unless you haven't just bought a device, I feel like I don't have to worry about it for at least another 6 months.
The reason I asked, you mentioned the key requirement on ARM technology. They have introduced a content filtering chip, and I just thought maybe in their next design you might consider making a firewalling application on it.
I hadn't heard of that, but I will definitely look into it. That's kind of my thing right now. Is people make fun of me because it's like, oh, Georgia just does bullshit at the application layer.
No, it's probably the best time to contact them because you can embed any suspicious calls as a detection in it, and we can stop it happening.
Yeah, I definitely want to look into that. So yeah, I'll write that down and see. Because I want to do stuff that's more. Because I originally did stuff at the baseband layer, and that was more exciting. So I want to go even deeper and start doing stuff at the chip level.
Have you been able to get at the service texts, or are they outside of your control?
At the what?
The internal operator service SMS that doesn't appear as a normal message.
Oh, I haven't done anything with it, but that's my answer to what I'm gonna do or try and do now that I can't with KitKat, and I assume later. that I can't just grab the ordered broadcast, but yeah, I'm just going to try and make it a service message instead. So I haven't implemented it yet, but that's the idea. I had to fix it.
You think you'll be able to own those at this time?
I haven't tried yet.
Okay.
Let's see. So it checked in, so there's the phone number of it, so now I can talk to it. These are all of the things that I can make it do as of right now, all the payloads I've written. So you can actually like pull an app off of it or something like that, so you could see what apps are on there. Like you can see all the installed packages and then actually upload one and then do like a pen test on it to find a vulnerability and whatnot. So kind of ridiculous stuff I like to write sometimes. But let's actually start by compiling this code to run. So I have, I just have this warftp interpreter.c. It's just really ugly C code that attacks warftp, and it's just got some shell code I dropped in, which the shell code can be for the Windows box because that's where it's actually going to execute. I just need to compile this exploit to run on a mobile device, and because I was having a really hard time with cross compilers after I got one built, I just put it in SPF. So I want to compile root smartphone pentest framework and exploits Windows, and it's warftp interpreter.c, and I'll just put it on the desktop because that makes it easier. Or FTP interpreter. And it threw some warnings because I'm a bad coder. What else is new? But it did actually compile it. When you go up there, it just says these are just warnings about me using bad stuff. But it did actually compile it. So then what I can do is actually drop it. So if I go to send commands to the agent and then I tell it I want to download a file, file to download, root desktop, or FTP interpreter, and where do I want to put it on the web server? I don't care, so I just kind of go like this, and what do I want to call it? Or FTP interpreter, and let's just have it deliver over HTTP, so that will tell it to download this file. It will put it in the files directory of that application. Every application is allowed to download files if it has internet. It can call out, but it can store files locally in its own private directory, but I'm just basically going to set it as executable so it'll run. So I give it a minute to download and make sure this guy is running, and this guy's IP address is what? You can also run nmap, like if you saw the list, it'll run nmap so we can find out what's out there and whatnot. Because there's actually already nmap for Android. I didn't have to build anything for that. 10.0.0.6. Alright. Alright, so the next thing I want to do here is I want to execute a command. There's also like execute a command and upload results, and there's also like run nmap, which will download nmap, execute nmap, and then upload the results. So you can kind of like build specific things to do lots of stuff together. But I just want to execute command. There's not going to be any output, so execute command is fine. So the command is warftp interpreter. And how I wrote this, I have to give it the IP address and port, but that's just based on the exploit code you wrote. But that's just how I did it. 21 for that. I need to make sure I have a listener, so I did just open up Metasploit over here. So this is just MSF console, and I just did use multi-handler, set the payload to Windows interpreter reverse TCP, which is the same one I used in that shell code here. So this is just shellcode I generated with MSF Venom. So a lot of the same things we did before are all the same. Just set the lhost option, and so it's listening. So this could be somewhere out in the cloud as long as my victim here has internet access, has the ability to call out to the internet. You could do this like with HTTPS traffic with Metasploit as well and get through most content inspection filters. So Metasploit has all of this in place. We're really just dealing with the mobile side. So I do have a listener. So if everything goes well, I should get Shell over here. So let's go ahead and run this. And it asked me, was this command downloaded? Because it will let you run system binaries as well, as long as the app has the permission to do so. But this one was downloaded, so it needs to know that it needs to pull it out of that files directory. So I say yes, delivery method, HTTP, and it should tell it to run that and exploit it. And assuming I didn't screw up my shellcode, which I've been known to do, we should see this thing explode here in a second. So it isn't instantaneous. You can change everything to be instantaneous, but just because of battery issues, I have it by default. It only checks in once a minute. So I just got a text message on my real phone. That's exciting. So we see it did get exploited over here. War FTP shows that it was exploited. It just shows a bunch of nonsense here. The fact that it's still alive and didn't die makes me believe that it actually worked. Occasionally when I've shown this, I've screwed up my shellcode or an IP address changed. Like if you watch the video from Hackfest, IP addresses just kept changing because I forgot my access point, and it was just a disaster. But this looks like it should have worked. So if I come back to my Metasploit here, I indeed do have Meterpreter. If you're not familiar with Meterpreter, it's basically a command shell with extra functionality. And there is Meterpreter for Android. It just doesn't do very much. My Android agents are much more powerful. But since we've actually exploited a Windows box, we have Windows Meterpreter. So at this point, everything will be your traditional pen testing things. You've just avoided having to do social engineering or find a client-side attack or anything on this Windows box that is probably behind NAT and whatever corporate controls they have. So we've just used the phone to exploit it. So, you know, let's see. People tell me that when I'm talking to corporate businessy people that I should actually make it do things. That, you know, when you're at a hacker conference, it's like Meterpreter, that's done, but like here are the password hashes on this box.
Mimikatz.
What was that?
Run Mimikatz.
It doesn't have Mimikatz in it.
Oh, never mind.
Well, actually, this one might. I just updated it, but yeah. But like, I could do anything that's on this list. Like, I could take a screenshot. I could key scan. I could execute any command. I'm actually only a user, but you know. But you guys, I watched you guys. You guys look like you know what you're talking about. So you know at this point I have control of this box, right? Okay. Well, I'm doing InfoSec World, so I know I have to like change something about the way I do these demos, because the first time I went to a business conference and I popped Meterpreter and nobody clapped, and I was like, okay, what do I do now? But it's like I need to read somebody's email or something, so I need to set something up so it's more like, oh, that's what it's about. But you know, if you guys have any advice on that, please let me know. I'm more of a technical person. So these are the password hashes. Hooray. So what we did in this demo was this first example. We didn't do that one. We did this one. So I talked to the phone. It attacked this guy, which sent it out just, well, in my case, it's all in the same local network, but you can see that could be a cloud system out here, my Kali box, somewhere outside of the network, and we would have to deal with anything they had at the perimeter. But Metasploit's pretty good. I've only really had one pen test ever where Metasploit's HTTPS payload wasn't enough to get out, because that'll even detect proxy settings automatically. So that's usually good enough to get out of most networks. But just in case it's not, you do have this SMS option as well, up until KitKat, so a KitKat device doesn't work, but I'm going to try and fix it. But, I've never had to. So it's about time they fix a vulnerability I found 3 years ago. You never know. So that's my demo for today. I hope it was exciting. It's not as exciting as the SMS shell one, but it pretty much accomplishes the same thing. In most cases, the SMS shell is unnecessary. So that is all I have for you guys. So here's my contact information, and I don't know if we have time to take questions, but I just had my website redone, so there's a lot of good information on there, and people had complained that documentation on SPF used to be pretty bad. In the process of writing my book, where I wrote a chapter on SPF, I actually also wrote a pretty good manual and did some videos. So if you're interested in SPF, contributing or just using it or coming up with ideas and telling me to implement them, please do let me know. Georgia@bulbsecurity.com, and probably the best place to get in touch with me is Twitter. So there's my Twitter. It's just my name. That's the only place I'm guaranteed to actually see it. Well, I will answer emails eventually, but Twitter's pretty instantaneous with me if I'm awake. So I'm not sure if we have time for questions, but I'm open to taking them. I can't hear you guys very well, unfortunately, but I've gotten some good feedback so far. I like the idea about working with the ARM processor very much, so, and also working with the control system SMS. So I will hopefully implement both of those very soon, and I will blame it all on you guys.
All right. Are there any quick questions? We've got one final session where we're going to take down the physical world.
Yeah.
I have a quick question.
Yeah, please. Scott, this is Scott Borg asking, Georgia.
Okay, I'm going to put myself back where I can see you guys. And I want to make it back so you can see me. Can you see me now?
Yes.
Yes.
Okay. All right.
So I have a quick question and a bit of information to offer. I love the demonstration. You said something about high-frequency audio being used as a covert communication channel, and I'd like to hear more if you have anything more to say about that. Also, I was wondering, since the phone companies cut off high and low frequency in order to economize on bandwidth, how is that possible?
Okay, so what I was talking about with that, what you want to do is just look up bad BIOS. I think most of it was probably made up. I don't really think, I think it's possible, like, if you had, I think it's possible as a proof of concept. I think with two computers you could definitely, like, set their microphones and their speakers and make it happen, but I don't really see it as something that could work on the whole as malware, but just look up bad BIOS. But for what I was talking about, I don't want to do high and low frequency stuff. I actually want to do text-to-speech and see how well that would work. Like, have my commands go through the text-to-speech, which is just built in. So it's more of like just me being curious, I guess, to see if I can do it, see if I can make a background call and then have it actually execute commands based on that. So it's just using a phone call as a communication channel. Everything that I've actually seen done has been like with SIP commands and whatnot. Like if you look at Ian Amit, I guess he was at Security Art then. It was at DEF CON 2011. He did a talk on, he used the VoIP communication basically the same way I use SMS to just avoid the perimeter to exfiltrate data or send your shell out.
I think, Georgia, you're going to be contacted by a number of people with a few really evil ideas. Well, what was that website from badideas.com?
GitHub/badideas.
So,
I can also offer a quick little bit of information. Starting about 11 months ago, we were seeing and being shown really high-quality spear phishing emails, so high quality that the alleged sender couldn't tell whether he sent it or not in a number of cases. And that was being accomplished by Trojanized smartphone apps that were being used to capture email so that then they could concoct plausible email.
well, George, I think you guys may want to talk, and I know Dave will be in touch as well. And George, I don't mean to rush you, but we're at a military conference here, and I'm 3 minutes behind schedule.